At the end of this video, you should be able to identify the visible and non-visible parts of the electromagnetic spectrum. Chapter 26, Section 1, Observing Space. Light enables us to see the world around us and to make observations. When people look at the night sky, they see stars and other objects in space because of the light these objects emit. This visible light is only a small amount of the energy that comes from these objects. By studying other forms of energy, astronomers are able to learn more about the universe. Recall that planets do not emit light. They reflect light from stars. Electromagnetic spectrum. Visible light is a form of energy that is part of the electromagnetic spectrum. The electromagnetic spectrum is all of the wavelengths of electromagnetic radiation. Light, radio waves, and X-rays are all examples of electromagnetic radiation. The radiation is composed of traveling waves of electric and magnetic fields that oscillate at fixed frequencies and wavelengths. Visible electromagnetic radiation. The human eye can see only radiation of wavelengths in the visible light range of the spectrum. When white light passes through a prism, the light is broken into a continuous set of colors as is shown on the screen now. Every rainbow formed in the sky and any color spectrum formed by a prism will always have the same colors in the same order. The different colors result because each color of light has a characteristic wavelength. Although all light travels at the same speed, different colors of light have different wavelengths. For example, the shortest wavelengths of visible light are blue and violet, while the longest wavelengths of light are orange and red. Electromagnetic radiation that has wavelengths that are shorter than the wavelengths of violet light or longer than the wavelengths of red light cannot be seen by humans. But these wavelengths can be detected by instruments that are designed to detect electromagnetic radiation that cannot be seen by human eyes. These invisible wavelengths include infrared waves, microwaves, radio waves, ultraviolet rays, X-rays, and gamma rays. Invisible electromagnetic radiation. If you place a thermometer in any wavelength of visible light, the temperature reading on the thermometer will increase. In 1800, the scientist Sir Frederick William Herschel moved a thermometer beyond the red end of the visible spectrum. Even though he could not see any light on the thermometer, the temperature reading on the thermometer increased. He had discovered infrared, which means below the red. Infrared is electromagnetic radiation that has waves that are longer than waves of visible light. Later, other scientists discovered radio waves, which have even longer wavelengths than infrared waves do. The shortest wavelengths of visible light, which are shorter than the wavelengths of violet light, are the ultraviolet wavelengths. Ultraviolet means beyond the violet. The X-ray wavelengths are shorter than the ultraviolet wavelengths are. The shortest wavelengths are the gamma ray wavelengths. At this point, you should be able to identify the visible and non-visible parts of the electromagnetic spectrum.